All right, we got the Algebra 2 DCA 2 review. The first question is asking find x in the system. Okay, this is a question, we've done stuff like this before. The only difference between this problem and the ones we've done before is that usually it would ask for the whole entire solution, except in this case, it's only asking for one part of the solution, that little thing right there, right? Okay, usually on a problem like this, we would have the solution that's x, y, z, the ordered triple. This one only wants to know what is the x. Okay, so if we're doing a problem like this, the way we've done them before is we have to have that matrix, right? We got to use the what's called the augmented matrix. Okay, tell me about the top row of this matrix. What numbers are we going to have? What numbers do we have in the top row of that matrix right there? We got 5, and then 1, 2, 24. Okay. If we're going across the middle, what are we going to have? -4, -1, -5, -23. And then across the bottom, 5, -1, +1, 19. Okay, so all we were doing right there is we were just taking the coefficients from x and y and z. Okay, that's what we're doing. These are all the coefficients of x and coefficients of y and coefficients on z, and then all of the constant numbers from the other side of the equal sign. Okay, that's what this matrix was. So what we're going to do is we're going to, in the calculator, we're going to hit second and then this button right here with the secondary function of matrix. And we're going to scroll over to math, and we're going to scroll until we find RREF. It's this one right here. RREF, and then we hit alpha zoom. And we need to know how many rows are in this matrix. What do we have? How many horizontal rows do we have? There's 3 rows. And how many columns? 4. Okay, so we're just going to scroll and select that. 3 and 4. And then all we got to do is put in those numbers, right? We hit enter. It gives us this matrix as a result. Okay, what does that matrix mean right there? 4, 2, 1. What does that represent? That's the solution, right? That's our ordered triple, x, y, and z. So we get 4, 2, 1. What is this question asking for? This question is asking for x, right? So all we have to answer is that very first one, 4. Okay, that's our x. X equals 4. Okay, so number 2, there's a bunch of problems. There's a bunch of problems on the test and on this review that are like number 2, where it asks you to write the system of equations, but you don't have to actually solve it. Okay, this is one of those. So when you read through that information, it's pretty easy to tell what your 2 variables are going to be, right? What do we have? There's definitely only 2 variables in this one. What are the 2 variables? The 2 items being compared. Nickels and dimes. Okay, so I'm going to say that x is my nickels and y is the dimes. Okay, if we've got nickels and dimes, how many coins do we have? There are 10 total coins. All nickels and all dimes put together is 10 coins. Okay, what does that look like in equation form? Straight up, just x plus y equals 10. Okay, this is going to be one of those problems where one of your equations is the number of products and the other equation is the amount of money. What is the total amount of money? There's 70 cents. So whatever's on the left side, the total amount on the right side is 70 cents. Okay, so all we need to know now is the individual value that comes from each variable, right? And we already know that a nickel is 5 cents and a dime is 10 cents, yeah? Okay, we already knew that, but the thing you have to be careful with here is that a lot of people write 5x plus 10y, thinking of 5 cents and 10 cents, but that's not what it is. Okay, when you're working with a problem like this, you have to put it in the decimal form. Okay, you have to think of 5 cents as 0.05x, and 10 cents is 0.1y or 0.10y. Okay, that's a very common mistake that I see. So if you see a problem like this that's asking about nickels, dimes, quarters, whatever, make sure you're putting the amount of the coins in decimal format. It's a very common mistake that I see on problems like this. Number 3, you've got 2 different ways you could solve this one. The first way you could solve this is algebraically, and that's where you just take this x and y and you plug them into the inequalities and see if they fit. The other way is to actually graph both of these and see if that point is in the overlapping shaded area. Okay, so doing it algebraically actually ends up being pretty quick and easy. Okay, you see that point that it gives you, that's an x value and a y value. And so if we substitute those things in, we get 1 on the left side, and we get 2 plus 1 on the right side. And you just ask yourself, is 1 greater than 3? Absolutely not. So since that inequality does not fit, since the point does not fit in the first inequality, you can automatically say, no, it is not a solution. Okay, if you were not sure how to do this algebraically, you could also do it using the graph, and that's why the graph was on there, so you could really do it either way. Okay, if we were graphing that first inequality, we would start at the y-intercept up here, and we see that the slope of this line would be 1. So we go up 1 and over 1, up 1 and over 1, all across like that. This would be a dotted line. And when we did the shading part, we would shade all of this area above it. Now, when you look at the point that it gave us, 2, 1, that's this point over here. It's not even in the shaded area for the first one. So how in the world is it going to be in the shaded area that overlaps for both of them? You see what I'm saying here? You really don't have to go very far into this problem to figure out that that is not a solution for this system. All right? That's really all you got to do right there if you're doing it graphing or algebraically. You really only have to look at that first one to figure out that it doesn't fit. Go on now to number 4. Some people looked at number 4 and they see that bottom equation where it's just 4z equals 36, and you can figure out that z equals 9, and then you can plug it into the equation up above it and you can figure out what y is. Okay, that's what the problem is asking for. It's asking us to find y. But in this case, I'm just going to do like we did on the previous matrix problem. Okay, I'm not going to go through it and put it all up on the screen here. I'm going to trust that y'all can figure it out. But one thing I do want to point out is the matrix itself, okay? Because you can see that these equations are a little bit different than the ones from number 1. Okay, when you have this set of equations right here, we have 3 equations. So how many rows should our matrix have? We got 3 equations. How many rows? We should have 3 rows in the matrix. Okay, the number of equations and the number of rows in the matrix is always the same every single time. And in each row, you're going to have an entry for the x coefficient, the y coefficient, the z coefficient, and the constant number on the other side of the equal sign. So the top row of this matrix is actually going to end up being pretty easy. You just got 4 and -2 and 1 and 15. Okay, just going straight across the x, the y, the z, and the constant. What is missing from the second equation? There's no x, right? So what do we automatically know has to go in this spot right here? You have to have a placeholder 0 to go right there. Okay, then you can keep going across with the y and the z coefficient and the constant. What's missing from the bottom equation? X and y. Okay, if we're missing x and y, we have to have 2 placeholder zeros. Okay, placeholder in the x column and the y column. Okay, then we can start putting the z, which is 4, and the constant, 36. Okay, you're going to do this same exact process. We're going to use that RREF function, and you're going to use this matrix to solve for it, and this time it's asking for the y value. Does anybody have that one? Off the top of their head, what do we got? It was 3. I believe that's correct. Number 5, we're doing more of that same stuff. Okay, except there's another problem here that's different from the previous one. What problem do you see in this top equation? Okay, so here's what I see. I see that we've got x on the left side, y on the right side. Normally, when we're doing all of this stuff, we want all of our variables to be lined up with each other, right? Okay, part of that is having all of your variables on the left in the right order and having all your constant numbers on the right. So if I'm dealing with this equation, x equals negative y minus 6, how do I get rid of this negative y to move it to the other side? What am I going to do? How do I move that negative to the other side? No, we don't subtract it. We're going to add it this time. Okay. Normally, if it's just the variable, you would subtract it over, right? This time we're actually going to add since it's already negative. Okay, that one's going to go away. We've got minus 6 on the right side. X and Y, can we put those together? Yes or no? Absolutely not. Those are two different variables. You cannot combine them because they're not like terms. Okay, so now instead of this equation that it gave us originally, we're now working with x plus y equals negative 6. This right here, we're going to do the matrix thing again. You hit second matrix, you look for RREF. That's this one right here. And then you go through and you hit alpha zoom. This time, we're not going to have 3 rows. How many rows are going to be in this? 2 rows. And how many columns? 3 columns this time. Okay, so what's going to go in that top row?
1.
We go 1, 1, negative 6. And what about the next row? 4, negative 9, and positive 2. So there you go. This one is asking for y. So which one of these is going to be the right one? This is the second one, negative 2. All right. Problem number 6, I think, is the first one that we're actually solving for something, right? We're not just writing the equations. We're actually solving from one of these word problems. Okay? This is the other type of word problem, by the way. On this first one, when we were doing when we were talking about the coins, this was the type of system where you've got one equation is the total number of items, and the second equation is the amount of money. This one down here on number 6 is where both equations are going to have to do with the cost of something. It's 2 separate purchases for 2 separate costs. Okay? If you can read through that, what are the 2 variables going to be? Apples and oranges, right? Okay, so let's say, I mean, they're listed as oranges first. Let's go with that. I'm going to say that X is the oranges and Y would be the apples. Okay, if we're doing oranges and apples, we've got 4 oranges and 2 apples. How would you put that in math terms? 4x and 2y, right? And what was the total cost for 4 oranges and 2 apples? $4. Okay, what about our second purchase? We had 2 oranges and 3 apples. 2x plus 3y, and what was the cost? $3.60. This right here is a system of equations that we can solve in the calculator. I'm not going to lie to you guys. We could go to all the trouble to multiply this bottom equation times negative 2, eliminate the x's, and then just combine the rest of your y's and your constants over here. You could do it. You could solve it that way if you wanted to. But if we have the calculator available, then why wouldn't we use it? You know what I'm saying? Okay? If we have the calculator available, let's use it to our advantage. So I come back over here, and I'm just going to put in those numbers going across the top. We got 4, 2, it was 4 oranges and 2 apples for a cost of $4. We go to our second equation. We had two oranges and 3 apples for the cost of $3.60. It gives us two numbers that go in our solution. We've got 0.6 and 0.8. I want y'all to think about this. If we've got 0.6 and 0.8, what is that when we're talking in terms of money? What does that mean? That's 60 cents and 80 cents, right? We're talking about 60 out of 100, 80 out of 100. It's cents, right? So when we see that, and we already said that X was oranges and Y was apples, it's asking what's the cost of each apple, right? So we're looking for what is the Y. In this solution, it's 80 cents. Okay, the cost of each apple would be 80 cents. Problem number 7, we did some like this on our homework, right? It says the perimeter is 20 feet. The length is triple the width. Okay, do we know what the length and width are? In this situation right here, do we know what the length and width are right now? Just from what's given? Absolutely not. Those two things, just like on that problem we did the other day, those are our two variables. Okay, so I'm going to say that X is the length and Y is the width. Those are the two things we would be trying to find in a problem like this. Now, I will say that it's really nice that we don't have to actually solve this. Okay, all we're doing is writing the system that represents this equation, or this situation, excuse me. Okay, so a lot of the problems I saw when y'all were doing this on the homework the other day, a lot of the problems I saw was just a misunderstanding of perimeter. Remember that on a rectangle, you've got two pairs of sides that are the same length, right? You've got two sets of sides that are congruent to each other. So it's not just X plus Y equals 20. It's 2X and 2Y equals the perimeter. Okay, that was probably the most common mistake I saw on that particular problem the other day, was just missing that formula, 2 times the length plus 2 times the width. This second sentence right here, this one right here, the length is triple the width. If you are tripling something, what are you doing? Multiplying times what? Times 3, right? So it's telling us that length is 3 times the width, yeah? Don't overcomplicate this thing. It's just 3 times width, okay? You don't even have to use X and Y, because in actual geometry applications, you usually just use L and W, right? Okay? That's all I'm saying. It's just 3 times the width. It doesn't have to be some overly complicated thing. I saw a lot of people on this question yesterday in particular were really overthinking the whole thing. A lot of these word problems, especially the ones that say do not solve, it is not a very complicated process to just translate those words into math symbols. Problem number 8, we got us another word problem. We've got 3 different water pumps, X, Y, and Z, that are taking water off of a flooded road. Okay? So when all 3 pumps are used, you get a total of 5,100 gallons per hour. Okay? If we're talking all 3 of the pumps, X and Y and Z, what is that in math terms? It's just X plus Y plus Z. Just straight up adding all 3 pumps all at the same time is a total of 5,100. When only X and Y are running, you get a total of 3,600. What is X and Y only in math terms? X plus Y, yeah? That's 3,600. When it's only X and Z running, what is that as an equation? X plus Z. Write the system of equations and do not solve. Boom. It's done. Number 9, which points represent solutions? Okay, so this one, it gave us the graph already. It's got the lines. One of them is solid, one of them is dotted line. It already showed you which one where the shading is, right? So what we are looking for is a point that is in the overlap shading area. Okay? We're looking for something that fits both inequalities. And the stuff that fits both inequalities is the overlap shading all the way on the right side of the picture over here. Okay? So we look at 0, 0, this point right here in the origin. Does that fit? Absolutely not. It is not in the overlap shading area. What about 2, 2 up here? It is shaded for one of them, right? But is it in the shaded area for both of them? No. So that one's not a solution. What about 4, 0 over here? Yes, it is. That one counts. 3, 1? What do we think? Okay, so here's the deal with 3, 1. It's on that line, right? It is directly on top of that solid line. Here's the deal with the solid and dotted lines, okay? The solid line, the whole point of differentiating between those two is that a solid line also has the equal sign, right? Okay? A solid line means that it's more inclusive than the dotted line, yeah? Because it's also including numbers that are equal to that inequality instead of just greater than or just less than. Okay? So if your point is on a solid line, then that counts. Okay? If it's on a solid line, that counts as being in the shaded area. So 3, 1 is a solution. But look at 3, negative 4, this point down here. 3, negative 4 is on the dotted line. Okay, the dotted line means that it's strictly greater than or strictly less than, right? So if that is the case, that means when it's on a dotted line, that point is not included. Okay, points that are on the dotted line are not included as the shaded area. So that means 3, negative 4 is not going to count. Our last one is 4, 2. Is that one going to count? Yes or no? Yes, it is. It's on a solid line. Okay? So solid line points on the solid line are included. And points on the dotted line are excluded. All right. Problem number 10, we've had problems that look just like this before where you write down the system, yeah? At least 2,600 in savings. Okay, when we see that word or that phrase at least, what symbol does that mean we're going to use? It's going to be greater than or equal to. Okay, so something is at least 2,600. And what are the two variables going to be in this problem? It's the two balances, right? The savings amount and the checking amount. So I'm going to say that X is the savings, because that's the first one that it gave us, and Y is the checking. Okay, those two account balances are the two variables that are being compared here. So we said that savings was at least 2,600. So that's X is at least 2,600. Okay, it could be more than that. It could be right at equal to 2,600, but it's never going to be less than that. Okay. This second phrase, the second key phrase that I see right here is this more than. Okay, that one's pretty quick and easy, right? We're just going to use that greater than symbol. Okay, savings balance is more than, so savings X is more than 3 times the checking. Don't overthink it, y'all. Savings is more than 3 times the checking. X is greater than 3 times Y. All we have to do is write the system. We don't even have to solve anything. Problem number 11. That is the same system that we had way back up here on problem number 1. Okay, you notice that problem right there? Okay, that 5x plus y, 2z, and all that? It's the exact same system that we have on number 11. All this problem is asking is what matrix are you going to put into the calculator? Okay? It's not asking you to solve it. It's not asking you to find x, y, or z or the order triple. any combination of them, it's asking what matrix are you going to put in the calculator. Okay, don't overthink a question like that. The next part of the question is what function do you select in the calculator after you hit those buttons? After you follow that sequence of buttons, you hit second and this x to the -1 button to open the matrix menu and scroll over to math. What do you select? It's RREF. It's this one that we've been using this whole entire time, right? RREF. Okay? Be careful on this. Very common mistake to accidentally hit REF instead of the one with 2 R's. Make sure you're hitting the one with 2 R's. Number 12. We've got all of our variables already defined for us. X, Y, and Z as sophomores, juniors, and seniors. The number of sophomores, juniors, and seniors signed up for a race is 1,250. Okay? What is that sentence represented in math terms? It's just straight up adding up all of those numbers, right? The total number of people signed up for this thing. X plus Y plus Z is 1,250. There's one equation. And what's even better is that this equation is already in standard form. Okay, you'll notice that's underlined at the end right there, right? It's asking you for the equations in standard form. What that means is that we want to have all of our variables on the left side in order, X and Y and Z, and all of the constant numbers on the right side of the equal sign. Okay, that's all we're trying to do is we're trying to arrange these equations so that they would be in the right format to put them into the calculator, into a matrix. Okay? So, look at that second sentence. I'm looking at there are 156 more juniors than sophomores. Okay? That is a complicated, that is kind of a weird sentence. That doesn't sound that weird when you just say it out loud, but if you try and put together the math translation of this, it's a little bit strange. Okay, 156 more juniors than sophomores. Okay, what that means is that the total number of juniors is the sophomore number plus 156, right? Okay, if it's 156 more than sophomores. So that means we've got juniors. What numbers? Juniors is Y. The number of juniors is the sophomores plus 156. When we look at that equation right there, is it in the right format? Okay, if it's asking for all of this in standard form, we have to get rid of that X and move it to the other side. How do I make that happen? Subtract it. That leaves us with 156 right there. And we've got negative X and positive Y on the left side. Let's look at that third sentence. The number of seniors is 103 more than sophomores and juniors combined. If you've got 103 more, first of all, what is sophomores and juniors combined? What is that in math symbols? That's X plus Y, right? Sophomores plus juniors. Okay? What is 103 more than X plus Y? That's just X plus Y plus what? Plus 103. Okay? So that's saying that seniors, our Z, is 103 more. So that's 103 plus the sophomores and juniors combined. Y'all see the issue with that red equation right there? X and Y are on the wrong side. How do I change that? We'll go minus X and minus Y. We'll just do both of them. Okay, so that equation is going to turn into negative X and negative Y and positive Z on the left side, 103 on the right side. Okay, this equation and this equation, the three that I've circled right there, those are the three equations that all go together. Okay, the reason we didn't keep them how we originally had it is because it was asking about this in standard form. Okay, standard form means that you're going in order with all of your variables lined up. That's what I wanted to emphasize on that problem. Problem number 13. We've had one like this before too. This one is asking to write a system of inequalities. And this is one where the second sentence is actually really simple. More than 10 hats. Okay, if we've got two variables, hats and shirts, I'll say that X is hats and Y is shirts. And hats has to be more than 10. What is that inequality? Oh, hang on. Do you see anything about shirts in that sentence that I highlighted? No, that's only about hats, right? So that's just straight up X is greater than 10. Okay? The number of hats has to be more than 10. So X is greater than 10. And that's it. Okay? The other key piece of information I see is here at the beginning, at least $250. What's that symbol for at least? Greater than, equal to. So something, whatever's on the left, is going to be greater than or equal to 250. What is that thing going to be on the left? It is going to have X and Y, but here's the thing. That 250 is a dollar amount, right? So if you've got money on the right side, you got to have money on the left side also. That's exactly it. It's going to be $18 for every X and $25 for every Y. Problem number 14, I'm going to trust that y'all know how to do this stuff in the calculator by now, right? Okay? Straight up, find the RREF of that matrix. Okay? This right here, y'all already know. That's the X coefficients, the Y coefficients, the Z coefficients, and the constant numbers. Okay, sometimes, I know we haven't done any problems that have that, but sometimes you see that vertical bar in between the coefficients and the constants. That doesn't actually mean anything. That's still one continuous matrix. It's a regular, 3x4 matrix. Okay, you're going to input it in the calculator same as you always do. Okay, just 3x4, RREF. That's all you got to do on that one. What did we get for that one, by the way? Does anybody have that? -5, I believe was right. Okay, it is asking for solve for Y. So you don't need the whole solution, the whole order triple. We only need the Y value. Problem number 15. I'm looking at trying to figure out what these two lines are. Okay, obviously this is a system of inequalities because you've got dotted lines and part of the graph is shaded. Okay, so we just really need to know what are these two lines and is it going to be a greater than symbol or a less than symbol? That's really all we need to know, right? Okay, so I look at the y-intercept of this diagonal line right here and it's -2. So if I'm trying to figure out the slope of this line, I'm just going to count up and over until we get to the next one that looks like it's on a grid point. And to me, I know it's kind of hard to tell. It looks like it's that one right there. Okay, so I'm counting up 5 and over 3 as our slope. Is that a positive or negative slope line right there? Are we going uphill or downhill? We're going uphill, right? So is that a positive or negative slope? Positive slope, okay? So I'm looking at positive 5 over 3 as our slope, 5/3 x, and our y-intercept was -2. So there's your mx plus b form. We know that we're going to have y on the other side. We just need to know is what inequality symbol goes in between. in between the y and the 5/3 x is going to be greater than, less than, or any of the equal to's. Okay, so I'm looking at this dotted line right here, and I know it's not going to be either of the equal to's, right? Because that is a dotted line. So we just have to look at, is it shaded above the line or below the line? Which one? It's above. So is that going to be greater than or less than? It's greater. Okay, there's that diagonal line. Let's look at this straight up and down vertical line. If you have a straight up and down vertical line, is that x by itself or y by itself? That is x. Okay, that is x by itself. This straight up and down vertical line is going to be x, and it's at the value of +3. Okay, that vertical line is at +3. We just need to know which side is shaded, the left side or the right side. This right here, that's the left side of that line. Okay, if we're shading on the left side of this line, okay, this part that's shaded like on this picture, this is the part where it's overlapping. Okay, this right here is the overlapped section of it. Okay, so if we were just dealing with this one line, all of this would also be shaded too. It's to the left side of that vertical line. So is that going to be less than or greater than? This one's going to be less than. Okay, think about this. All of these points that are on the line have an x value of 3, right? All of these points to the left of it, their x values are all less than 3. Okay, like this over here, this is like the point -4, 0. That is a point, that x value, -4, is less than 3, right? Okay, all of these points that are shaded from it have an x value that's less than 3. So that's how we know. If you're really not sure about it, it's the left side, and this arrow is pointing to the left, is it not? Okay, that's how we know. Our last one, number 16, it did not print the actual equations. It only printed the question off. But if I'm remembering correctly, it was 2x plus 2y equals 4, right? And then negative x plus, was it plus 2y? Plus 2y equals -2. Okay. It's asking the question, what do you multiply times the second equation to create the like or opposite coefficients in the x? Okay, that's saying if we're doing elimination on this system and we're trying to eliminate the x, what do you multiply this bottom equation times? Times 2. Because if we were trying to create opposites, that's what you would do, right? You would do the whole entire thing times 2. Okay, that is your answer. Is just 2. Okay, the question isn't asking you to solve by elimination. It's not asking you what is x, what is y. It's not asking you what the solution point is, x and y together. It's asking, if you were doing elimination, what would you multiply that second equation times? And that's it. All right, don't overthink it. That is all we have.